what do you guys want to, what kind of problem do you guys want to start by reviewing? What's up?
Ones that equal to each other.
Okay, so like a solving problem. Okay. So let's look at some solving examples, and I'm just going to make some stuff up. So there's kind of two different situations. Let's not do that. So this situation where we just have the two fractions equal to each other, this is called a proportion. To solve one of these, the most effective first step would be to, okay, so you could check to see if there's any factoring to do, because maybe you could reduce this and make it a little easier. In this case, there isn't any, so we go to cross multiplying. So that's good. So after you've cross multiply, you're still left with an equation, right? Like the equal sign doesn't go away or anything. What should we do at this step? Foil these things out. Very good. And I'm just going to do that foiling quickly in my head in the interest of time. Is everybody okay with that? Okay. All right. Now that it's foiled out, what do we do after that? Sure.
Since you cross multiply, I'm confused how you got x3. Why would it just stay the same?
So like these two get multiplied together, which is what we have here. And then these two multiplied together, that's what we get here.
Oh, so it would be like x squared minus 12. Just bring the...
Well, we are going to multiply them out, but to multiply x plus 3 times x minus 4, we have to foil.
You have to get that into the fraction?
So like, yes, we want to get it out of the fraction and then we'll foil.
Well, and you get out of the fraction by cross multiply.
Correct. Okay, so at this step, when I have these two polynomials equal to each other, what do I need to do next? Fraser?
I don't know if it's like reducing it from one side, putting it all on one side.
Good. Yeah, exactly right. We'll put everything onto one side. So we subtract the x squareds from both sides. We'll add the x to both sides and then add the 12 to both sides. So I have a 0 over there. And what I'm left with this time is a quadratic equation. How do I know it's quadratic? They have the x squared. Perfect. Is it always going to be quadratic? No, not necessarily. If there's no x squared, is it harder or easier? Much easier. Because you can then just like subtract the 7 and then divide by 2, right? If there's no x squared there, if when you move everything onto one side, all the x squareds drop off, that's a good thing, right? That just makes the problem easier. That didn't happen in this case, though, so we do have to solve this as a quadratic because of the x squared. To solve a quadratic, what should we do? So we can use the quadratic formula. Yep. So that is x equals negative b, oops. So that's negative of a negative 2 plus or minus the square root of b squared minus 4ac all over 2 times a. So negative of a negative is positive. Negative 2 squared is 4. 4 times 1 times 7 is 28. 4 minus 28 is negative 24. Over 2. If we have a negative underneath a square root, that creates an imaginary. Everybody okay with that? Andrew?
Could you just, like, which one should we, like, solve first, like, inside the square root? Even -2.
Yeah, so I would do the -2 squared minus 4 times 1 times 7.
Oh, okay.
So I just did that all at once. Like -2 squared is 4.
Yeah.
And then 4 times 1 times 7 is 28.
And then you
4 minus 28 is -24.
Wait, so what's the formula?
So it's x equals -b plus or minus square root b squared minus 4ac all over 2a.
Will we get the cheat sheet back?
Yeah, you stapled it to your test, so.
I'm just making sure, 'cause I
Yep.
had that written down, I would not remember
Yep. And this answer right here would be okay for me. You could do a little bit more, and I'm not going to worry about that right now because that answer would be fine once you get the I out of there. It doesn't simplify down, like there's not, 24 isn't a perfect square, so you could do a little bit better, but like I'm not too worried about that at this point. Is that okay? Leo?
Can't you get rid of the 2?
Well, I mean, you could write it like this way.
Okay, yeah. Oh. Oh, okay, I see it.
But you can't just get rid of the 2's. So you can reduce the part in front of the plus or minus, but it still has to stay on the other part, the denominator. So like, again, that's okay too, but is it any really better than the other one was? I don't know. Does that feel okay on that? The other situation is like a clearing fraction situation. That's going to be 10. 5x, 6x. So I need to. Okay. So this is an example that's not a proportion, right? Because we have the two fractions added together on one side here. What should we do first here? Andrew?
The least common denominator.
Okay, before we can find the least common denominator, though, we need to factor. Yep. And the x squared plus 5x plus 6 can factor, right?
Yes.
What does that factor to?
Plus 2 plus 3.
Very good. Yep. I knew what you meant. So our least common denominator would be?
X plus 2, x plus 3.
X plus 2 times x plus 3. Everybody okay with how we did that? Okay. So I'm going to multiply that to both sides of my equation. So when I write this thing all out, I'm going to get something that looks like this. Everybody cool with what I did there? So basically I just took that least common denominator and I'm multiplying it to everything in my equation, right? To each fraction. So let's reduce these, since these are all, we have like 3 little multiplication problems going on. So in this first multiplication problem, the x plus 2's and the x plus 3's can cancel, and I'm left with just negative 10x. In the second pair, the x plus 2's cancel, and I'm left with x times x plus 3. And in the last piece, the x plus 3's cancel, and I'm left with 5 times x plus 2. And I made a boo-boo here. I want this actually to be negative 11. Sorry, guys. Anyways, continuing on. Everybody okay? All right. So what should I do next? Okay, to do that though, what do we have to do first? I have to multiply everything out, and then we can move everything onto one side. Good with that? So those can distribute through. Oh, pooper scoopers. Anyways, I'm going to make another change again because I goofed it up again. Anyways, so moving this onto one side, I'm going to subtract the 5x and then subtract the 10. So on this side, we have 0. For here, we have x squared. 3x minus 5x is negative 2x. And I guess really what I want this guy to be is 5x is what I guess I meant that to be. So 5x gives me, and negative 2x gives me positive 3x. I'm sorry, I just wanted something that was going to be factorable at the end. I just was trying to do it in my head, and these aren't easy to get to work out nicely in your head, so I goofed it up 2 times on when I made the problem. I thought I had it right the first time, and then I miscounted, and then the second time I forgot that the things were on different sides of the equal sign, and they're, anyways, you don't care. Okay, so this can factor, right? Or if you didn't notice that it factored, you could still use the quadratic formula. Either would be okay. So multiplies to give us negative 10 and adds to give us positive 3 are 5 and negative 2. So when I set each of those equal to 0, I get negative 5 and positive 2 as my answers.
So if it's not factorable, then you use the quadratic formula?
You can always use the quadratic formula. Even if it is factorable, that's fine. I just chose not to use it because it's easier not to use it if it's easy to factor. Grace?
Do you always get 2 x's?
Well, a quadratic, the solution to a quadratic equation is always going to give you 2 answers if you're counting multiplicities. So if you could get the same answer twice, right? Like you get 2 and 2, like the same answer 2 times. But a quadratic's always going to give you 2 answers. Vanessa. Yeah, I meant that to be 5. So, yes, it was, if the original problem, you were correct. All right. But one more thing we have to check here is to make sure that these answers aren't extraneous, right? We should have done that on the first one. I didn't because we got an imaginary answer and the imaginary answers can't be extraneous, but this one could be. So what I'm going to do is I'm going to take -5 and look at what I get when I plug it in to the denominator in the original problem. If I plug -5 into x in any of those 4 places, do I get a 0? No, right? -5 plus 2 isn't 0. -5 plus 3 isn't 0. So -5 is fine. That's a good answer. And then I'll do the same thing with the +2. Do I get 0 from any of those? No. So that answer is also good. If one of them did give me a 0 denominator, I'm just going to cross out that answer. That's it. Did that help with the solving parts? Okay, what should we talk about next? We still have a good 15 or 20 minutes. Sure. Where to? To here?
Just want to see when you multiply these coming up.
So wait, would that first number be a 5 as well?
Yeah. Yeah, these are all 5x's. Is what I meant.
Multiplying x plus 2 at the end, or to the first fraction, what did you multiply it by again?
So this is the least common denominator. Applies to every fraction of the problem.
Can you just put over 1?
Yep. Every time over
Multiply
1.
straight across.
Yes. Well, I'm going to reduce. Hopefully there's not really much multiplying that has to be done, right? Because we're canceling these things out. So there's not much left to do. You just end up with like a couple of things left.
Okay.
You know what I mean, Walter?
Yeah.
Okay. What do you guys want to talk about next? Do you need a minute to just like breathe this in? Then say so, guys. It's fine. We're doing this for you guys. I know how to do it. If you need just a minute to process, be like, just give me like 60 seconds to like sort through this in my head for a minute before we move on. That's cool. You know, just say something. It's not a big deal. Okay, Andrew.
I don't know, did you do one like, there was one on the test where the fraction had like, it was all like added, it was like x plus, I don't know, but I didn't know how to do it.
Well, I'm not going to do the test question,
Well, yeah.
but if you can describe to me kind of what you're thinking of, we can talk about it.
Ones where you can get, like, where you can factor it out, but there was no ability to factor it out.
One. So
Just
are,
like x plus 1. And then
It was like x squared plus something, x plus something,
okay,
on top and bottom.
okay.
I didn't know how to solve for it.
So this is a solving problem you're describing? Or is this like a multiplication problem or an addition subtraction problem or?
I don't remember.
Okay. So I think,
It was like the first one of the, it was like one of the first 2 questions.
okay, so I
There
think
was no equal sign.
there was no equal sign, so it wasn't a solving problem. So I'm going to tell you right now, like, all of the things that look like they should have been able to be factored could be factored.
Okay.
So if you couldn't figure out how to factor it, it was factorable. You might just have been trying to do the wrong thing. So remember, there's 2 major that we have to like factor things. You can just take out like a greatest common factor. Or you can worry about multiplies to give and adds to give. If you have a trinomial.
So where did the 7 come from?
It's just a separate.
This is separate. separate example. Yeah. Or you might have something that you have to combine these two ideas with. Right? Like I can take out the 2, and then I can factor the stuff that remains. So again, like those are the 3 types of factoring that you'll probably have ran into on the test. I tried to really limit myself to one of those 3 situations and not do anything like too kooky. Yeah, Stefan?
Can we do graphing?
Sure. Does it matter which form it's in, whether it's the a over x minus h plus k or the ax plus b over cx plus d?
Could we do the y equals a over x minus h plus k?
Mm-hmm. Okay. This situation, right? So, this is in this form. In this form, you needed to remember that the vertical asymptote is x equals h, and the horizontal asymptote is y equals k. So in our situation, the vertical asymptote is 3. We so far so good there? Okay. So the domain is basically everything except that vertical asymptote. And the range is everything except for the horizontal asymptote. Yes, sir?
So on the test, should we write A and R and then all that stuff? Because I just put like the number.
You should put yeah. So ARN stands for all real numbers.
Okay.
And basically you're saying everything except for 3, which is what the domain is in this case. So we'll maintain our table needs to be that vertical y coordinate that goes with the vertical asymptote. And then we'll just pick some values that are 3 values less than the vertical asymptote, 3 values greater than the vertical asymptote. Doesn't matter what they are. I usually just pick whole number things that are right in a row like that because it's convenient. And now I just need to plug these values of x, or these x values in to the x's in my function to get the y. So for the first one, I'd end up with 2 over 0 minus 3 plus 1. So that's 2 over negative 3 plus 1, which is just negative 2/3 plus 1 is positive 1/3. Trust yourself to do that kind of mental math in your head, which is totally understandable. You can use your graphing calculator to kind of handle a lot of that.
Okay, quick question.
Sure.
So the actual equation has a -3.
Mm-hmm.
Does that make it a +3 because it's x minus h? Or does it
Correct.
say, okay.
Yes. So the h is just always going to appear to be the opposite of the sign in the equation.
So when you write in your calculator, you're writing x plus 3?
No, calculator is
Okay.
exactly as it appears.
Okay. That's real messed up.
The sign flipping is only for finding the asymptote.
Okay.
Is this going to open for me? Will you open, you stupid machine? I swear I've clicked this button for my calculator emulator like 6 times and it just is like, no, I don't really feel like opening. Oh, displaying. I was open. I just wasn't coming to the front. All right. Will you turn on or not? You guys can all see me clicking the on button and doing nothing, right? Oh, there, it finally did something. All right, so I have to go and change my mode and stuff. I had it set up for stuff to do for a different class, so don't mind what I'm doing right now. All right, so what I'm going to do is I'm going to go to the fractions menu. So to do that, I'll do alpha and y equals, and I'll choose the first option, the numerator over denominator. And then I'll put 2 in my numerator because that's what it looks like in my function. And then my first x is 0, so I'll type 0. And then I'll do my minus 3. And I'll move my cursor so it's outside of the fraction. And then type my plus 1. And then to make sure I'm getting a decimal, because I'm going to want to plot this, it makes it easier to plot with decimals rather than fractions. And press the math button and choose the decimal option. And then press enter. So there's my 0.3. And now to get my next one, I'm going to go back and do the same thing and enter a 1 instead of a 0. But the easiest way to do that is press second and enter. It'll give you the exact same last thing you had up. And then you can just scroll back and edit that to have a 1 in there instead of the 0. And just press enter again. And we can keep on doing that. And this is, I find, the easiest way to do this, is it saves you a little bit of button pushing and having to sort through all those menus. If you can get it set up correctly once, it's not so bad, because you're just going back and editing one little piece of it. Come on. Okay. And I'm just going to kind of continue. Stefan, you still good?
Yep.
Okay. And this looks hopefully pretty easy to do, right? The hard part is just getting it set up once. And then you can just not really change anything. You're just going to kind of go back through and edit one little part of it. Okay. So if I go to graph now, so here's my vertical asymptote at, here's my horizontal asymptote at, so 0 and 0.3, 0 or 1, 0, and 1 or 2, negative 1. So that's going to look like this. And then 4, 5, 2, and 6, and 1.6, look like that. Is that okay?
Yeah, I don't know how I messed up so bad.
You know what? It's easy to kind of get frustrated and turned around, you know? You get nervous and you start overthinking things, and, you know? It is easy when you've done it for 20 years, you know? It makes it look really easy. It's not that easy if it's your first time, so don't, you know? Okay. Did you guys feel any better?
Yeah.
Okay. You ready to pass these bad mama jammas back and take another pass through?
Yes. Yeah.
Okay.
Quick question.
Yes.
Okay, so for the, whenever you're multiplying the least common denominator, instead of writing out like the whole denominator when you're multiplying it, can you just multiply what isn't in that fraction? Like if he has a piece of that
what you're asking is, can you go,
Like instead of, so.
you want to go straight without writing down the previous step, basically, right? That's what you're asking?
Yeah, I think it gives you the same answer.
Stefan, my answer would be, that's okay, provided you've identified the least common denominator somewhere and showed that you're multiplying both sides of the equation by that. That's okay. Like I've done up here where I have, like I'm multiplying both sides by the LCD and identify that is. If you went straight to this step, that's okay.
Like instead of multiplying like x plus 2 and x plus 3 in the second, I would just multiply x plus 3.
Right, which is what we've written down here, right? So yeah, I think is what you're asking.